This here is my first IoT button, standalone button, battery powered. You push it, it sends a command, and we can take action on the command. This is actually built as a party button for my kids. The idea being you push the button, and using some of the home automation stuff I have set up, it starts a party, it pauses the TV, it turns on party music in the whole house, and then it changes the hue lights to different colors every second. So this was my first kind of experience with the ESP8266, using batteries, using the chip. This box I 3D printed, and it works well. We use it probably every day. It's got a lot of use. You can see it's pretty dirty. At least one of the kids comes up and says, can they push the button every day to do a little dance party, which is great, but it needs some improvement. So my plan now is to make Party Button V2 and probably use some of the thoughts and ideas in that to piggyback on a generic kind of IoT button that I can use for various things around the house, not just parties. So I'll give you a quick explanation of how this works. Effectively, what the screen is right here, you can see it is showing the power on. This is an MQTT system that I'm signed into, and when I press the button, see, I'll show you here. This is another flaw. When you press the button, you can see the blue light flicks. The bounce of the button, there you go. So now it's sticking. So now it's working. Come over here. It's booting up, and the power on triggers, which would then the home automation system would read and react to. So all it's doing is connecting to Wi-Fi and then sending an MQTT message. Pretty standard. Inside here, we have two AA batteries, basic. We have a Node MCU chip with the ESP8266 on it. We obviously have the button, which is just tying a reset. Actually, it's just resetting the chip. We have a boost converter, which takes the two AA batteries and puts it to a 3.3 volts so that this can run correctly. We have an LED which shows that it's been activated, and I'll explain that in a minute. And then this is a push button circuit, which I'll link in the description. What that does is it allows me to shut the power off completely to this chip. And it's important for these chips because they're not very energy efficient. So this chip will shut the power completely off until you push the button, or this little push button on there. And then it will start the chip up, which basically resets it, runs the code, which sends the empty, connects to Wi-Fi, sends a message, and then the node will then trigger this chip to shut completely back off. That works okay. For a pretty simple design, I mean, there's not many passive components because everything's basically on this board. The LED was introduced because of the issues that when you press this, sometimes it doesn't work, depending on how you press it. The kids would hammer on it, and it just wasn't working. I needed some visual feedback that it was actually working, so I added that LED that's driven high when the chip actually starts. So it's an indication that it's actually working. So all in all, it works. It's big, it's clunky, it's power hungry. There's a lot of components. If I do the math on this project, I think it was $30 to do this box as is. This is a while ago. Now it would be about $20 to build, mostly because the Node chip's expensive. This is buttons like $5, regulators like $4, then you get some battery components, the button, printing out the box, etc. So the idea for the new button was to make it simpler, standardize it in some kind of way so that I could reuse it easier, powered off of LiPo batteries instead of just AA, so I can recharge them. I'm not 100% sold on that idea just because they're a lot more expensive, but I could also use rechargeable batteries as well, just normal AA size rechargeables, because those are much, much cheaper than the LiPo, but these are smaller. So ideally, if I build a circuit that I can reuse and put into smaller buttons, this flat form factor will make a big difference. Here are the components that I'm going to use to build the new button. Ignore this programming jig for now. We have obviously the 8266 chip, and it's an ESP-12F form factor. So that is the microcontroller plus Wi-Fi. Got a whole bunch of passive components. We got 5 10K resistors. This little guy is an HT7333, which is basically a power regulator, LDO, to get the 3.7 volts from this LiPo down to 3.3 so I don't burn the chip. And then a few capacitors to make sure that all the power is stable. I'm changing this cord over to it's a little bit bigger and thicker, mostly just because I have hundreds of these. Where is this? I don't have any of the size, so I'm going to just convert the battery over. All these components will be shoved into a box. A button will be added, and it will come out similar to this. So here's party button V2. I assembled it last night. It was pretty straightforward to get going. This print took, all in all, about 5 hours. I'm not thrilled with the case, but I can revisit that in the past. And if we look, push the button, and you see it does the same thing. So it basically fires off every time I push the button, and you could have this do anything you wanted. I'm just having it do the party button currently. So all these electronics that you see right here are basically just shoved into this box. Little cleaner, maybe. You could argue, maybe not. The button is an arcade button. I didn't have any more of those other buttons, so I just used the arcade button for now. The LiPo battery, I printed this little holder for, which slides in and out, and it plugs into the board down there, so you can just unplug it to recharge it. You can see the ESP-12 right here. It's kind of pointed out for the antenna, and the capacitors, the power supply is down here on this little perf board, and then there's some resistors and some pin headers right here that if I need to program it again. And that's it. This all enclosure, except the battery, $5 to build. So that counts the button, that counts the enclosure, that counts all the electronics, everything except the LiPo battery. The LiPo battery is about $5 too, so that doubles the price, but still this button comes in at half the price of the original button at $10, so I could reproduce this easily for $10. It is more energy efficient because it doesn't have all the other passive components that Node MCU has. It's basically just a simple ESP8266 chip, and I can deep sleep it. So I'm also removed all the circuitry for the push button because now I'm just resetting the chip when the button is pressed and it wakes up from deep sleep. I remove the voltage regulator chip that's a boost because it was running on 2A batteries. Now I'm just regulating down to 3.3 from 3.7 with this simple voltage regulator. That makes the circuit much easier. It's also faster. I'm not sure why. I haven't really debugged why it's faster. That one can take 2 to 3 seconds, if not longer, to boot up, where this one usually takes, on a cold start, 1.5 seconds, and if you hit it repeatedly after that, it's about a half a second. It might have to do with that push button circuit that's in that one that doesn't exist in this, but I haven't dove into the details of that. Here's the code for the button. Very simple. It comes in about 70 lines. We connect to Wi-Fi. That's what it is. We're defining some MQTT information, the topic, client ID. These are some constants about waiting, retry times, and how long to wait before I go into deep sleep. And all of this, you notice that the loop method is actually empty. We're not looping at all. What we do is in the startup function, we're going to set up the Wi-Fi, set up the MQTT, we're going to publish the MQTT message, and then we're going to deep sleep. So it never actually gets to the loop. This deep sleep 0 just says deep sleep forever until I'm reset. That's all that does. So Wi-Fi is standard. It just sits there and waits until it's connected. And then once that's connected, it then calls the setup MQTT, which connects to the MQTT server, username and password. Once that's connected, I then publish the message. And in here, I was doing some experiments. That's what this code is left over. Up here, you can see the start time I record. As soon as the setup function is started, I save the start time. And then down here, where I'm actually about to publish, I record how long it takes to get to this point to publish. So this basically encompasses the Wi-Fi, MQTT, all that stuff starting up. It was to monitor how long it took. That's how I know it takes 1.5 seconds on a cold start and 500 milliseconds on a warm start, because I was publishing that right here. I then changed it to this, so it was consistent with the party button already. That way I didn't have to change any of the home automation code. And then this delay here is just to give this publish some time to actually get over the wire before we go into deep sleep. If this wasn't here, this message wouldn't be published because it would basically try to publish in the deep sleep instantly. So this code I'll post in the description. It's very, very basic. Again, there's not much to it, which is good, clean, fast. And let's see if I have... I don't have the schematic, but I will link the schematic to this setup that I'm using here for this particular button, also in the description. So this is my party button V2, but it's also a very generic IoT button. So I could use this now to trigger any home automation I want, any light that's hooked up to that. And in fact, one of the projects that I'm working on right now does something very similar with so here's some other examples of buttons in different cases. I kind of like the square better. I might go back to a square. Same idea, right? These are just basic, simple buttons that I can have do anything I want. And I'm working on also kind of sequence this one, which has multiple buttons. But the same ideas hold true. They got all these components. Actually, it doesn't even need, so if you want to do battery, if you want to power it off the wall, you just need this. So we're talking about $2 with some passive components, maybe 50 cents in total. So $2.50 for all of this stuff. And then you get the button and the enclosure. It's about 50 cents to $1 closure, so that's not $2. So under $5 you can get a button. And if you powered it through the wall, which is normal USB wall wart, you are not using this expensive LiPo battery, it'll be much more efficient, and you don't have to sleep, so the reaction time for button pushes would be much quicker. Anyways, different topic. I'll probably talk about that when I get to mass producing these to use around my house. But anyways, Party Button V2 works great. Kids started using it last night, and I will post all the information below in the description.